Welcome to our next video on Elasticsearch Security. Today we're discussing DataSunrise, our comprehensive data security suite that includes many useful features such as data audit and masking. As you remember from our previous videos, we use native Elasticsearch audit and its role-based access control for hiding data from unprivileged users. Today we will use DataSunrise software for audit and masking. We begin with configuration, databases, and add a new database for our Elasticsearch server, which is currently running on this same Windows machine. We select Elasticsearch database and database type. We enter localhost as the server hostname and provide a password for the Elastic user. Let's test the database connection before saving. We've got an error because I didn't set the protocol type. Now the connection is OK. I scroll down to the Save button, and this concludes the instance creation. We now have the Elasticsearch instance to protect. DataSunrise provides proxy port number 9201 for Elasticsearch connections, which is completely transparent for any client software thinking it still works with Elasticsearch directly. The new Elasticsearch instance updates its metadata, and we can create rules for auditing our queries and masking. Note in the expanded instance description there's a proxy port number. This differs from default Elasticsearch port because it's running on this port, and our operating system can't provide the same port for both proxy and original Elasticsearch server. Let's start with some preparations. As you probably know from our previous videos, Elasticsearch is queried using HTTP request methods like GET, which is used by web browsers, post, delete, and so on. I've opened Postman and pasted the prepared curl command with a put request. This creates test index. We'll use its documents and their properties for our audit and masking experiments. Note that despite pasting the curl command with username and password, Postman transformed them into a single base 64 encoded string. This isn't really secure as it can be easily decoded, but this is outside the scope of today's discussion. Now we create 3 documents in this index using post requests. These are for John Doe, Jane Smith, and Bob Wilson, and contain their department and email. Let's query all the documents using GET request and match all query. We've got the data in Postman connected to Elasticsearch directly. DataSunrise didn't know about these HTTP requests. Now we change a single digit in the port number and we'll do the same match all request. We'll get the data through the proxy, which in turn gets this data from Elasticsearch. The proxy mode is just one of the deployment modes available for DataSunrise. We use this mode as it's the most powerful and feature-rich. Notice how we switched our client software, Postman, from unsafe data source to protected one with just a single-digit change in the port number. Let's create an audit rule. Navigate to Audit and Rules and press Add New Rule button. We enter the name for the new rule and choose the instance we created moments ago. Save the rule. Now let's run the match all query again. This should be audited, and the log entry should appear in transactional trails. We can unfold the query column to see that this was indeed a match all query to the test index. The number of rows corresponds to the number of returned documents. Now it's time for masking. How we actually protect sensitive data while keeping the rest of the database useful and avoiding major infrastructure changes. Navigate to Masking, Dynamic Masking Rules, and press Add Rule button. As usual, enter the rule name and instance, which is Elasticsearch in our case. Here are the masking settings. You can set different fields and documents for masking here. This is a highly flexible tool as it allows dynamic masking based on data contents as they're requested. We select Test Index here and save the selection. I want to leave the department and the name unmasked, so I've removed them from the masked data selected objects. Now we say the rule in masking should work. Instead of email, we will see an empty field in the JSON returned from Elasticsearch. Indeed, email is empty. There are dozens of other masking methods available. When your software relies on the existence of this field, DataSunrise can mask email strings partially or use format-preserved encryption. Another feature I want to show is that masking events can also be logged. You can see if masking occurred not only as a data consumer, but also as the database administrator. For this, let's enable Log Event and Storage checkbox and save the rule. Now, I send a couple of GET requests to Elasticsearch through the DataSunrise proxy, and we'll see the events in the dynamic masking events page. All good so far, but we skipped an important question on masking. Can DataSunrise decide what data to mask for which user? This is set up in the masking rule as well. We should configure the filter sessions block in the rule setup. There are multiple variants of session attributes to filter. We need DB user, but there are no users at the moment. Let's import Elasticsearch users into DataSunrise. Now that we've imported the user, I can set the rule. Remember, we also have the limited underscore user with the simple password 123. This means if I set the filter for limited user, their queries will be masked and logged at masking event page. Queries for Elastic will not be masked and will be displayed by DataSunrise. This concludes our brief introduction to Elasticsearch Security with DataSunrise. We hope you found this video useful, and we invite you to check out our other videos on database security on our channel.